Here we're going to continue using the properties of parallelograms to again solve for variables, possibly on the diagonals, possibly on the sides, possibly in the angle measures, just using all those properties of parallelograms that we looked at. For number 5 here, I'm going to first use these two sides. They're opposite sides, so you can set them equal and solve. So I'm going to say 8g minus 3 equals 25. And I'm just going to solve that. I'm going to add 3 to both sides. So 8g equals 28 and divide by 8. And so g is going to be 3.5. For the value of g. Moving on to the next part of this, I've got this angle here and this angle here. They're not opposite angles, so they're not congruent. They are consecutive angles, and consecutive angles are supplementary. They're adding to 180. So I need to add these together equal to 180 degrees. So I'm going to combine my constants before I even set up my equations. So I'm going to write f plus 72 and 30 is 102. So if I'm adding that up, so these two together are equal to 180 degrees. So I combined the like terms before I wrote it down. And then to solve, we'll just need to subtract 102 from each side. So 180 minus 102 would be 78 for F. Number 6, we've got our diagonals marked, and if this is a parallelogram, the diagonals will bisect each other. That means that the 9 is equal to 2n minus 1, and that m plus 8 is equal to 3m. So I'm going to use that to solve for n and m. I'm going to start with the one with the 9 and the 2n minus 1. So 2n minus 1 equals 9. To solve, adding 1, 2n is 10. Dividing by 2, n is 5. So that's the first one. And then the other one, m plus 8 equals 3m. So I'm going to start solving by subtracting m to get the letters together. Gives me 2m on the right. Divide both sides by 2, and you see that m is 4. Continuing on, we've got another one with the diagonals labeled. So again, the diagonals bisect each other. So I'm looking at this one here. 3j equals 5j minus 9. I'm going to subtract the 5j. So I got to get my letters together, and I don't want to leave it empty on the left side. That'd be negative 2j equals negative 9. And divide by negative 2, j would be 4.5, would be positive 4.5, because negative divided by negative is positive. And then the other one would be k plus 10 would be equal to 6k. So I'm going to subtract k from both sides. 10 equals 5k, divide by 5. 2 equals k. So k is 2 here for that one. Looking at the next thing, find the indicated measure in a parallelogram. This is a symbol for parallelogram, A, B, C, D. So I want you to remember that your sides are parallel, and so that can do some things with these angles. Right here, I'm going to draw in, I always notice this, the alternate interior angles, the Z shape that I'm drawing in to show you. This angle up here where there's the 23 is congruent to this one here because they're alternate interior angles. So I'm going to start by labeling those the same. And the 80-degree angle, if you're looking, going this way, is another Z shape. And so this 80-degree angle is the same as this angle here. another thing I'm noticing is that this 117-degree angle in the middle, it's vertical to this one above it, so those are both 117 degrees. And then it makes a straight line with this one beside it, and so if I subtract 180 minus 117, I get 63 for the one beside it here. And this is vertical over here, so those are congruent. And then I'm able to find the missing angle, like the other angles that I haven't labeled yet, by knowing that each triangle adds to 180 degrees. So if I've got 23 in the bottom left and 117 right here, if I add those together, that would be 140, and that would leave 40 degrees for this one right here. And then alternate interior, this one up here would be 40 degrees. And then if I've got 80 and 63 right here, that would add to 143, and that would leave 37 for this other angle in this triangle, and then alternate interiors would put this 37 here as well. So using parallel lines, alternate interior angles, vertical angles, linear pairs, and the fact that a triangle adds to 180, I can label all my angles. Then I need to look over here. They're naming them with 3 letters, so A, E, B, so playing connect the dots, A to B to E. A to B to E is surrounding this 23-degree angle. So that one's 23 degrees. B, A, E. B to A to E surrounds this 40-degree angle. And the letter in the middle is where the angle is, but you have to look around it to see, is it the whole thing at A, or is it which side at A is it going to be? So see, this one has E in the middle, so it's going to be in the middle, but there's 4 angles there, so we got to look. A, E, D. Start at A, go to E, go to D. That's a 63-degree angle. E, C, B. Start at E, go to C, go to B. That's surrounded the 80-degree angle. B, A, D. Start at B, go to A, go to D. That's this whole thing at the top, so you need to add the 80 and the 40 together. That is 120 degrees. D, C, E. D to C to E surrounds that 40-degree angle. A, D, C. A to D to C. You have to add these 2 together at the bottom. That would be 60 degrees. Adding the 37 and the 23. And then the last one, D, C, B. D to C to B, you have to add the 40 and the 80 together. That's 120 degrees. All right, here's the last problem in this section of notes. So just 2 videos for this section. The diagonals of parallelogram VWXY intersect at point C. Find the coordinates of point Z. Well, what we know is that the diagonals always bisect each other. That means that point Z is the midpoint of each of the diagonals. And you only have to do this formula with one of the diagonals. I'm going to use Vx and find the midpoint of it. So the midpoint of Vx is Z. And we're going to figure it out using our coordinates. V is at 0, 0. That's why I picked that point to use, because it is the really easiest point to use. And then if I'm looking at x, let's see, 1, 2, 3, 4, 5, 6, 7. Double counting, 1, 2, 3, 4, 5, 6, 7. Yep. 1, 2, 3, 4, 5, 6. It is at 7, 6. So x, 7, 6. There we are. So we need to find the midpoint of this, which means we need to add our x's and divide by 2, and then add our y's and divide by 2, and see what we get. 7 over 2 and 6 divided by 2 is 3. You could write it like that, or you could write it as a decimal if you want to, 3.5 comma 3. That would be where z is at. And you could do either diagonal, just do the midpoint of it, and you'll find the coordinate for the point where the diagonals intersect.